Hey everybody, this is Joshua Dice, and this is my video project for Letu University. As you can see, we have a easy little substitution problem right here, but we need to move it around. Mind you, this video's got to be about 6 to 10 minutes long, so let's really think through this as we should with every math problem, which is something I've learned recently is really important in math. So this is a quadratic equation. No, not the quadratic equation, but it's in a quadratic form. So what is that form? It's the standard form, right? So we need to get this equation into a ax plus bx, ax squared plus bx plus c equals 0 form. And we're close to that. Can you see that? That's a little small. Well, I'll try to write bigger. I write generally pretty small. But anyways, so the easy way to get that over there is by adding 16 on each side, plus 16. Oops, that's a 6. Now it's 16. And we'll write x to the 4th power minus 8x squared plus 16. All right, so now, oh wait, hold up. We need equals 0. There you go. Now we have an equation. Otherwise, it's just an expression. So what's different between ax squared plus bx plus c and this one is that we don't have the squares at the b actually, right? Well, you would think that, but what you can actually do here is a substitution problem, and that's what the whole video project's about, right? So this is what we're gonna do. If you think about it, really, x to the 4th equals x squared times another square, right? Times 2. Is the 2 is being multiplied by 2. So what we can say, since x to the 4th equals x squared times 2, or I don't actually know how to say that. I hope you can get my point there. What that means is that we can substitute a different letter in for x to the 4th. We can say that x squared equals, and that could be any letter, it's just a variable. So let's go with, well, my name is Josh, so let's go with j. All right, j equals j. So now we have x squared equals j. So x to the 4th equals j times 2, which would be j squared, right? I guess you'd say x squared squared, right? And so now we can rewrite this in a substitution. J squared, 4 times 4, minus 8j, just j, not squared, because this is equivalent, plus 16. There's no variable here, right? There's no variable going on right there, so no need to worry about that. Equals 0. Now what we have to do is factor out this equation right here. So j, what would this be? J minus 4, j minus 4, right? And we can check that over here with a, let's just make sure you see that. My hand's covering it up. And so FOIL, right? J squared. That one, negative 4j, and then negative 4j, and then that last 2, which will make that positive, right? And so we add that together, we get j squared minus 8j plus 16. Perfect. That's what we have right here, all right? Equals 0, right? So now we can take this and we can solve for each section, right? We can solve for each expression. So j minus 4 equals 0, right? So we make that an equation, or j minus 4 equals 0. And I know it's a double thing, but it was a problem I made up, so it's just simple, right? For concept understanding's sake. So you add 4 to both sides on each equation. And I actually don't know if we should solve them at the same time. I like to go step by step, right? That's how algebra goes. So we have j equals positive 4, and j equals positive 4 in both of these. So now this is where the substitution comes in, right? We had substitution right here, and now we're gonna have substitution right here. So we bring our boy x squared back, right? Since j equals x squared, we can put j right here. J becomes x squared equals 4, and x squared equals 4. Seeing that all right? Awesome, good. It's just barely above my head. It's kind of funny. Now, what we have to use is we have to implement the square root property, which says if x squared minus a would be the number, then x equals the square root of a, or x equals the square root of negative a for all the non-negative real numbers a, right? So basically that means boom, boom, we just take the square root of this, right? Because we need a normal x. We can't have x times x equals the number, because actually that'd be x times x equals number times number, which is exactly what we get here. So x equals plus or minus 4, not 4, oh my goodness, plus or minus 2, because 2 times 2 equals 4, but also negative 2 times negative 2 equals 4. So we get that basically twice, and that would be our answer. But we're mathematicians here, so we're gonna check, right? So let's check. Now we enter the original equation, x to the 4th minus 8x squared equals negative 16, right? And we will see what we can do here. So we'll put in 2 for that equals negative 16. So what's this? So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That's 4 2's. And then we'll have 2 squared, which is 4, and then 4 times 8 equals what? 4 times 8 equals 32, right? 32, I'm saying that right. Negative 18, so then, sorry, 16, negative 16. We get 16 minus 32, which equals negative 16, checks out. Now, we could write it all out. Just checking our time here. All right, we're doing great on time. And real quick, all we got to do here is check this again with the negative 2, right? Because it's plus or minus 2. What we're doing here is we're trying to find out if both of these are solutions to the equation. So just basically the same thing. Since we have even exponents right here, I can write this out. So we have negative 2 times negative 2. That's going to make that a positive 4. But then once you multiply another negative 2, that makes that a negative 8. But once you multiply the last negative 2, that's so long as it's an even number, it's going to be positive. So just like positive 2 to the 4th was 16, so is negative 2 to the 4th equal positive 16. And so that also is going to make this what we said up here, which was negative 4, which makes that 32. So positive 32 again, which just like the last time made this negative 16 equals negative 16. So that's my video project. I hope you enjoyed. I hope you understand what I'm all saying. I appreciate you, Mr. Porter, Professor Porter, for being my teacher, and really enjoyed this class. So thank you for watching, and have a blessed weekend. Bye.